Welcome back. So today, now that we've talked about all of the properties of logarithms, now we're going to move into talking about how to solve equations involving exponents and logarithms. In the first piece of chapter 7, we did dive into exponents. However, now we're going to take it a step further to solve any equation that is exponential. Now, my first strategy is when I can rewrite the bases to be the same, then I can use a strategy that we kind of talked about back in chapter 9 in the geometric sequences. So let me show you what that looks like, okay? So here, 16 is a power of 2. So I'm going to rewrite that. 16 is 2 to the 4th power, okay? Now, you saw this back when we were doing geometric sequences, is when I had the situation arise, what I could do is now say the only way that this is a true equation is if my exponents are the same. Okay? And now I just solve something linear. Subtract 1, divide by 3. So the solution is x equals 1. So, pretty basic. And again, it's an idea you've actually already seen. So this shouldn't be that new to you. Of course, we're going to make it more complex than we did before, though. So let's take a look at this. Now, 16 and 8. Okay, 8 can't be written as a power of 16. However, both can be written as a power of 2. So 2 to the 4th to the 3x equals 2 to the 3rd. Power for power means to multiply, so that's ultimately 2 to the 12x equals 2 to the 3. So again, I've rewritten them so they are the same base. Because they are the same base, now the only way that this is a true statement is if these are equal, if the exponents are equal. And now divide by 12. 3 divided by 12 leaves me 0.25. All right, what about this one? This one looks a little bit harder, but remember, 125 or 1 over 125th is really just 1 over 5 to the 3rd, right? 125 is 5 to the 3rd. I don't want it as a fraction, so the way to undo the fraction is to bring it up, okay? And to bring it up, I need to apply a negative exponent. So this one takes a little more work to maneuver them to have the same base, but now you can see what you're dealing with is that. Okay, I was able to rewrite the 1 over 125 to be a power of 5. And so now that I've done that, now my exponents must be equal. Okay, is the only way that that can be a true statement. Subtract 1, here x is going to be negative 4. All right, now, if there's anything else being done to the equation, you do need to make sure that you handle that first. All right, so what I mean by that is here, I need to divide the 3 first. So divide the 3 off of both sides. It cancels that. And this gives me 49. 49 is the same as 7 squared. So now that I've rewritten it like that, now that the bases are the same, the exponents actually have to be the same. And that means x is going to be 1. Or what about this next one? So this next one has multiple steps that have to occur before I work on rewriting it. I'm going to subtract the 3 away first. Negative 61 minus 3 is a negative 64. I'm going to divide both sides by negative 1 to cancel the negatives. Now I'm ready. Now I'm to the point I can rewrite 64. What is 64? Well, it is 4 to the 3rd power So my x is going to be 3. That's the solution to my equation. And this one here, 27 is 3 to the third. So power of a power is going to multiply into that exponent. Okay, so 3 times the quantity x plus 1 will give me 3x plus 3. Well, now my bases are the same, so that implies my exponents have to be the same. Subtract 3x from both sides. So x minus 3 equals 3. Add the 3 over. X is going to be 6. So that's my first strategy. Okay. What's my second strategy then? Well, sometimes the numbers can't be rewritten. Okay. Sometimes it doesn't work that way. So what can I do in that instance? Well, in that instance, I'm going to have to use logarithms, okay? So, in using a logarithm, I'm going to take the base logarithm to be the base of the exponent, okay? So in this case, what I'm going to do is to both sides of my equation, I'm going to take them to the log base 15. Okay? Now, the reason I'm doing that is because we've had this conversation before that logarithms and exponents cancel each other. So all that's left on this side is the exponent itself. Okay? That the log base 15 cancels that base of 15. So now I'm left with this equation. Okay? So again, you use the base log that's the same as the base of the exponent, and that cancels off that, and all you have left is the exponent itself. So now I want x log base 15 of 285 divided by 3. All right, now this is where we needed that change of base formula, okay? Because you can't just type that into the calculator, unfortunately. So remember the change of base that we have to do, okay? So this piece right here, in the calculator, I'm going to have to type in log of 285 divided by log of 15. All right, that's why we took time on change of base. It's because this is where we need it. So let's go to our calculators. So log of 285 divided by log of 15. So that's log base 15 of 285. And then we still have to divide it by 3, okay? Because it was that divided by 3 that gave me x. So this is what I want. And again, still 4 decimal places. We're going to keep with that rule of thumb. So what I want is 0.6958 as my answer. 0.6958. So that's going to be the answer to my logarithm. What about this next one? So let's move on to here. So again, I can't rewrite 100 as a power of 2, okay? It's not going to work this time. So I take both sides to the log base 2. Again, the log cancels that base of the exponent. So on this side, all I have is x plus 5 equals log base 2 of 100. And now I need to subtract the 5 off. So it's log base 2 of 100 minus 5. And again, this right here, when I go to type that in the calculator, okay, remember, what I'm going to have to do is really log 100 divided by log 2. All right, you can't calculate those in the calculator, so you have to use the change of base. So let's go and do that really quickly. So log of 100, oh, I'm sorry, divided by log of 2 gives me that. And then remember, I still had to subtract 5 to get my x. So here, my x is going to be 1.6439. And there is my x. All right, now also make sure you recall that if other things are happening, take care of those first. So I'm going to subtract off that 1 first. Now that it's isolated, now I'm going to take both sides, log base 3, 3 to the 2x, log base 3 of 189. I'm using the log to cancel off that base, so now I have something that I can calculate. Now I'm going to divide by 2. But of course, in the calculator, that is really going to have to be written as log of 189 divided by log of 3, because the calculator can't handle doing that. So let's get an answer for this. So go to the calculator, log of 189 divided by log of 3 gives me that. But now I still had to divide, I believe, by 2. Yes. So now I take that and I divide it by 2, and there is my answer, 2.3856. All right, and now let's look at this one. So let's take that 87 and we need to divide that 2 off. So we're going to have 4 to the 2x plus 1 equals, oh, not logging yet, equals 43.5. So let's log base 4, both sides. The log cancels the base of the exponent. So we have 2x plus 1 equals log 4, 43.5. So now let's do some algebra manipulation here. All right, so I'm going to subtract the 1 and then divide by 2. Now here, that looks like a mess. All right, so let's be really, really careful with how we're going to plug this into the calculator, because I want it to stay as exact as possible for as long as possible. So let's talk about how to accomplish that. Well, again, remember, this has to be written as log of 43.5 divided by log of 4. So let's do that piece first, okay? Oh. So log 43.5 divided by log of 4. All right, so I have that piece done. Now let's subtract the 1. That's the next step. And now let's divide by the 2. So if you carry through step by step, you can keep your answer as exact as possible up until the very, very end, where now we have to say round to 4 decimals and get 0.8607. 0.8607. And there's my answer. All right, so now that we've accomplished that, now let's talk about sometimes we get some nice cases. So here when we're talking about a base 10, all right, that actually gets really nice. So first let's divide off the 3.5. So I'm going to get 10 to the x plus 4 equals 40. 40 can't be rewritten as a power of 10, so I'm going to log both sides. So we get x plus 4. Now base 10, remember, we don't really have to show. So I can just do that. Subtract 4. Now the nice piece is log 40 can already go straight into my calculator. So because it's already that common log, I don't have to manipulate it this time. I can just type it in completely as is. So log of 40 minus 4, boom. I can just type it in and get my answer. I didn't have to do change of base because it's already a form my calculator could recognize. And that's going to give me negative 2.3979. Negative 2. Let's make sure I do this right. 3979. And there's our answer. All right. So let's take a look at a word problem, and then I will let you go so you can write your summary and come back ready to do your practice work. So what is a sustainable, renewable, natural resource when you manage forests properly? Your lumber company has 1,200,000 trees. You plan to harvest 7% of the trees each year. How many years will it take to harvest half of the trees? All right, so this is very similar to the first half of chapter 7, okay? This would be an exponential decay situation. So we only want half of the trees left. So that would be 600,000 being left when we're starting with over 1 million. Oh, not equals. If we're harvesting 7%, that means 93% are going to be left. And we want to know how many years will it take. So this is the cool thing is previously you had to make a table to solve this situation. However, now we're to the point you can use a logarithm to handle this situation. So divide off the 120,000, or sorry, 1,200,000. You get 0.5 equals 0.93 to the x, okay? So now I have to take the log of both sides. So log base 0.93 of 0.5 equals log base 0.93 of 0.93 to the x. And remember, those cancel each other. So this is my computation to get x, all right? Now, I can't type it into the calculator though. So remember to type it into the calculator, really what I'm going to type in is log 0.5 divided by log 0.93. Okay. Excuse me. So let's go and type that in. Log of 0.5 divided by log 0.93. That's going to give me 9.5513 years. All right, so that's kind of a cool thing is now those problems back in chapter 7 that we had to make tables for, now you can solve with logarithms. And I think that's really cool to show you how this wraps back around. So wrap up by writing the summary for me, please. And a great one would be compare and contrast the two solving methods for this. Then come back ready to do your practice work.